Just wanted to remind you that on this channel, the majority of the videos that I publish deal with mathematics. So I have a bunch of mathematics tutorials. Also have another channel, Tony Pereira, where I have, again, videos on math, dealing with basic math up to calculus. In this particular channel, I also include stuff on technology and miscellaneous things like plumbing and so forth. So, but the majority are going to be math. The last video, I went over factoring binomials that involve the difference of squares. Okay, in this particular video, I'm going to look at factoring binomials where you have a difference either of sum or difference of cubes. Okay, so here are the main formulas. The first one here, difference of squares. If you have a difference of squares, in this case x squared minus y squared, factors into the difference and the sum of the square roots, x minus y, x plus y. Okay, the focus for this video will be the next two formulas. Difference of cubes here, x cubed minus y cubed, factors into the difference of the cube roots, that's x and y. Okay, those are the cube roots of x cubed and y cubed, respectively. And then the second factor is obtained by squaring the first root. Okay, that's x squared. And notice now the sign goes from here minus to plus, the product of the roots, xy, plus the square of the second root. Now for the sum of cubes, x cubed plus y cubed, notice pretty much the same except the signs change. So it's the sum of the cube roots, that's x and y, and then the square of the first root minus the product of the two roots, that's xy, and the square of the second root. In this case, of course, we're dealing with cube roots. So notice the similarity in the two formulas. All the terms are the same except for a few sign changes there. Okay. So let's look at some examples. Okay, so this one I have a difference of x to the fourth and 64x. So x to the fourth minus 64x. The first thing you want to do whenever you're factoring, whether it's a binomial or a trinomial, always look for a common factor. So notice that in this case, x to the fourth and minus 64x have an x in common. So we factor out the x. Okay, we factor out the x, what is left? Okay, well, the first term becomes x to the third, and the second term becomes 64. Okay, always make sure that if you multiply it back, you get the same thing you started off with. Okay, so then you look at what you have and see if you can continue the factoring. So in the parentheses, x to the third minus 64, I have a difference of two cubes. 64 is 4 to the third. 4 times 4 times 4, so 64 is a perfect cube. So I can apply the formula on that part. So the x comes along, and then x cubed minus 64 factors into the difference of the cube roots. So the cube root of x to the third is x. The cube root of 64 is 4. And then the second factor is obtained, we look at the formula, by squaring the first root. Okay, the first root is x, so you square it. And then the sign changes, so that becomes a plus. Look at the formula. And then it's the product of the two roots, that's the x and the 4, so I'll write that as 4x. And then it's a plus the square of the second root. In this case, the second root, in this case, of course, is a cube root, is 4, so you square it, we get 16. And that's your solution. Now, I do want to point out that these formulas here, you can verify the formulas by multiplying the expressions on the right side and simplifying, and you should get the expression on the left side. That'll verify that the formulas are true. Okay, so that's your factorization, complete factorization. So we clear this. And remind again, if I'm going too fast on these, just kind of pause the video and look at the result that I have. So clear this. Go to the next one. Okay, here I have 27x to the 5th minus 165x squared. You can see they both have x, so we can take out a factor. Now you can take out an x, but always take the largest power possible. So in this case, I can take out an x to the second. Take out the x to the second from the first term. That will leave you with 27 x to the third minus 125. Okay, so again, if I multiply through, I get the same thing I started off with. And then you, again, examine the result to see if you can continue the factoring. Okay, in the parentheses, I have a difference of two cubes. 27x to the third is a cube, and 125 is a cube. Okay, it's 5 to the third. It's 125. 3x to the third is 27x to the third. So I can continue factorization. Okay, so x squared comes along to the right, and then I have the difference of two cubes. So I take the cube root out, 27x to the third. We say that's 3x. And then cube root of 125 is 5. It's 5 times 5 times 5, or 5 to the third is 125. And then the second factor is obtained by, again, squaring, that's one of the formulas, squaring the 3x. So you square that, you get 9x squared. And then remember here, the sign here is opposite of what we have in the parentheses. So this is a minus and this is a plus. That's from the formula. So it's plus. And then the product of 3x and 5 is 15x. And then it's plus the second root squared. So square it, that's 25. Okay, so that's your complete factorization right here. X squared, 3x minus 5, 9x squared, plus 15x plus 25. Now, I want to point out to you that if this had been a sum here, okay, so let me just, that's the answer to that one, but just we're dealing with either a difference or sum of cubes. So if I make this a plus here, then this would be a plus here, and this then would be a plus here, and this would be a minus here. This would change to a minus. Okay, that's the only difference in the formulas. Okay, so I have the sum of cubes. This is the factorization. Clear this? Okay, the next one's kind of interesting here because I'm going to look at x to the 6 can be written as x squared cubed. Okay, remember the law of exponents here, you multiply the exponents, so 3 times 2 would give me 6. So x to the 6 then, and the same thing applies to y to the 6 here. If I put a y to the 6 here, this will be y squared and so forth. Those are perfect cubes, okay? But I can also write x to the 6 as x to the third squared. X cubed squared is also x to the 6. And of course, the same thing applies if we put a y there instead of an x. So this tells me that x to the 6 and y to the 6 are perfect squares and they're also perfect cubes. Okay, so here you have an option. You can use difference of squares or difference of cubes. Okay, now I'm gonna use the difference of cubes formula. So I'm going to say x to the 6 factors into, okay, difference of the cube roots. So the cube root of x to the 6 is x squared, and the cube root of y to the 6 is y squared. So I get this. And then the second factor then would be the square of that first one, the first root. So square x squared, that'd be x to the 4th. And then it's plus, and then it's a product of the roots. And then it's plus the square of the second root. So this will be y to the 4th. Okay. And then I look at x squared minus y squared. That's a difference of squares, so this can be factored further into x minus y x plus y. And then this gives me then x to the 4th plus x squared y squared plus y to the 4th. Okay. Now the problem here is that this x to the 4th plus x squared y squared plus y to the 4th can be factored. Okay. Now let me show you, before I finish this one, let me show you how it works if I look at this as a difference of, let's look at this as a difference of squares. Okay. I use the formula for difference of cubes here, and this is what as far as we got. But if I use difference of squares, then this becomes x to the 3rd minus y to the 3rd. Okay, so in other words, I'm saying this is equal to over here okay. So I factored into this. So here I have the difference of cubes and the sum of cubes. So I would continue to factor. Okay, so I'm going to factor the first one here. Difference of cubes. Okay, so this would be x minus y. Difference of the cube roots. And then again, just using the formula for the difference of cubes. This would be then the square of the first one. That's x squared plus xy plus the square of the second root. I get this. Okay. And then the second factor, this x cubed plus y cubed, I use the formula for the sum of cubes. So the first factor then would be the sum of the cube roots. So this would be x plus y. And second factor is just the square of the first root minus the product of the signs, of the roots rather, x and y, plus the square of the second root. Okay, so let's look at the two answers. This answer over here, where I use the difference of cubes, I got x minus y and x plus y, so there's x minus y up here, and there's the x plus y. And then over here I have this expression, x to the fourth plus x squared y squared plus y to the fourth. So that means that this then, if this up here is correct, this should factor into these two factors. This one, the product of this factor and this factor. And it does. Okay. So it's a little bit tricky, but here's what I'm going to do so you can see this. So let's just focus on this part right here. So this is x to the fourth plus 2 x squared y squared plus y to the fourth minus x squared This is a little trick, yeah, I guess we could call it, that's used quite a bit in mathematics in order to justify or prove certain concepts. So all I did is I added x squared, y squared, and subtracted it. Okay, so notice if I subtract the x squared, y squared, if I subtract the x squared, y squared from the 2x squared, y squared, I get the same thing I started off with. Okay, so this right here is the same thing as what I have in this parentheses right here. Okay, so in other words, I'm just adding 0. Okay, I'm just adding 0. But this then, if I look at this right here, that factors into x squared plus y squared times x squared plus y squared, or I'm going to write it as x squared plus y squared squared minus x squared y squared. Okay, x squared plus y squared squared minus x squared y squared is the same thing as this expression right here. That, just by simply adding 0. Okay, so what I'm doing here is I'm trying to show you that this then is going to factor into this factor, x squared plus xy plus y squared, and x squared minus xy plus y squared, because this is just a difference of squares. Okay, this is just a difference of squares. So if I apply the formula here, let me just do this. Okay, so difference of squares. So the square root of x squared plus y squared squared is x squared plus y squared minus the square root of x squared y squared is xy. Okay, so this is one factor, and I'm running out of room here, so I'm going to put the other factor below this, and the other factor would be x squared plus y squared plus the square root of the second term. Okay, so I'm using the formula for the difference of squares, which is what we covered on the last video. Okay, so this x squared y squared minus xy is this factor right here. Okay, and this x squared plus y squared plus xy is this factor over here. Okay, so I can get the correct answer whether I go difference of cubes or difference of squares. But you see, you don't have to go through this little trick here if you use the difference of squares. So if you have an expression, a binomial, you took out a common factor and it turns out to be difference of squares and also at the same time difference of cubes, then I would go ahead and just use the difference of squares formula and then continue with the regular procedure. Okay, and that will work out a little bit easier for you. But either way, it can be done. But this second method here will involve a little trick here. Okay. That is, if you use a difference of cubes, it's going to be a little bit more difficult. You have to go through this little trick here. Okay. So that concludes this video. Next video coming up, we'll deal with, again, with some miscellaneous, I guess I would say, little plumbing things I want to go over with you. So thanks for watching. We'll see you in the next video.